So the amount of mass contained in a volume. Okay, so here's the symbols that we're going to use. Units. Right, so usually when you're talking about density, physics books, chemistry, engineering books, they usually use the symbol rho, the Greek letter here. It's kind of like the P, but not really. It's a little off center, I guess, but I can never really draw Greek letters properly. But oh well. Just remember, it's rho. Units will be in kilograms per meters cubed, assuming we're in SI units. Okay. So density is not the same as weight. For example, 1 pound of feathers weighs the same as a pound of bricks. Right? Well, obviously we know that, but they have different densities. Bricks have a higher density than feathers. Okay, so just do some questions here. So the question you'll see in your practice problems or homework 4 will be this type of stuff. Just find the density. Rho given a mass equal to 14 kilograms and a volume equal to, I'll write down here, 20 centimeters cubed. And so you just use your formula. It's nothing crazy, right? So rho density will be mass divided by volume. So that's how you got to do it, really. So it'll be 14 kg instead of freaking h. Divided by 20 centimeters cubed. All right, so that will be, let's see what the decimal will be, right? It'll be 7/10. Yeah, so technically we 0.7 kilograms per centimeters cubed. But we usually have those in meters cubed. So I say we change it before we do it, just to remain consistent. And so they told me the units are kg per meters cubed, and I think I'm going to try to stick with it. But I don't think it matters. I'm just being paranoid. But just for fun, right? What would it be? So centi means, you guys remember what the prefix meant for C? Let me pull it up for you guys. 1 second. Excuse me. So C should be 20 times 10 to the negative 2 meters cubed, which would be 14 kilograms over 20 meters cubed, and I can bring that 10 up top, right, using our math skills. So when it's all said and done, that would be 70. Just make me move it twice. Kilograms per meters cubed. Skipped a step there. That's only if you want it in meters cubed, but question didn't specify. Okay. So I'm just going to do both, just in case it comes up. So here's our final answer. Here's all right. Density of the biofuel is 0.72 grams per centimeters cubed. What is the mass of 1 liter of fuel? So we have the density already, right? So we're looking for M. So we know that rho is equal to M over V, which implies that the mass is equal to rho times V, right? Density times volume. So we need volume. You have density. You have the 1 liter. But 1 liter is not in centimeters cubed. So we can change it. That way we can get our mass using the same units. So let's see. So we plug everything in. We have our density, 0.72, because this right here is in centimeters. So I'm going to try to put everything in centimeters. I'm not going to use the liters, because if I use liters, that would not cancel, right? My centimeters. I want to get to mass, it better be just grams. Multiplying by 1 liter wouldn't help us at all. So we need to figure out, we need to look up or know how much it needs to be. So they gotta tell us or we gotta find it. So it's about 10 cubed centimeters cubed in 1 liter of fuel, biofuel. This is how much volume it is in centimeters cubed. 10 to the third. So this would cancel the centimeters, right? Volume units, leaving us with 0.72 G's times 10 to the third. But 10 to the third, we know, looking at our prefixes, right? That should be K. Let's check. Right? Let's look at this thing over here. See how K is 10 to the third. So I can just change that to kilograms, right? kgs. So this will be simply 0.72 kilograms. But you could multiply that in and move the decimal, but then it wouldn't be, it would be like what, 7,200 grams or something like that. 720. All right, move on to pressure. Pressure is a force acting over an area. So here are the symbol and units that it uses. This time it actually is a P. So I'm sorry if you can't distinguish between my P's and rho's, but forgive me. I didn't write the word rho next to it, so please understand that pressure will be in P, which is more appropriate, right? So pressure, the equation we're going to use is the force divided by the area. And the units vary quite a bit depending on metric, what we're talking about. Like, I think we have pascals. Let me write them all down right here. PA, pascals, VAR, ATM is atmospheres, millimeter, HG, there's another one, inches of H2O. And of course we have PSI, which is the one we're used to in America. I believe it's pounds per square inch, PSI. Okay. In chemistry and other science journals, I usually run into atmospheres and pascals. I have not run into the other guys as much. But anyway, here are the units for some of these guys. Pascal is PA equal to newtons divided by meters squared. So right away you can kind of tell which one's the SI unit, right? Which one's the American unit. PSI is pound force per inch squared. So for every square inch, you have a pound of force. That's what the wind's telling you. Okay, 1 atmosphere is equal to, this is just a conversion factor that you will need later, equal to 14.7 psi, or 101 kilopascal, kPascal. All right. One second. All right, here we go. 1 atmosphere is, let's define it here, it's atmospheric pressure at the level. Okay, so whenever you see 1 atmosphere, that's basically saying Earth's atmosphere at sea level, right? That's the pressure we're comparing it to. That's how we define it. Gauge pressure. Gauge pressure is a pressure in relation to the local atmosphere. So if you're measuring in atmospheres, that's what we're talking about. Okay. Let's give some examples here. We're using a basic gauge like for blood pressure or tire pressure. That type of stuff. You see PSIG, that's usually in negative when it's relating to vacuums. So this is called vacuum pressure. So if you see 10 psg, we're saying that it's basically negative. Understood to be. Okay. Absolute pressure is the pressure related to a vacuum, which would be This is usually 0 psi. Okay. The units that we designate this with. The absolute pressure. It's just like we set up here. We put the unit A to show, for example, PSI A. That would be absolute PSI related to a vacuum. Okay. Okay. And it is equal to gauge pressure plus atmospheric pressure. And here's what I'm saying in this basic equation. Absolute pressure is equal to the gauge pressure plus the atmospheric pressure. Okay. So for example, let's say you have a P gauge equal to 35 psi-G, right? You would have to add the atmosphere that we're in. That would be equal to, hold on a second, 35 psi on the gauge. That would imply that we have 35 psi-G plus 14.7 psi, because that's one atmosphere. So that would be equal to 49.7 psi-A. So if I want to change it to absolute, and if we're just talking about a regular atmosphere, right, just add one atmosphere, so this is here, to get your absolute. Okay. All right. That's the hydrostatic pressure. So hydro implying, of course, water-like liquid. So hydro meaning liquid / fluid, something like water, whatever. Static meaning it is not moving. When you hear static, it's at rest. So when dealing with the pressure of fluids, the density of the fluids must be taken into account. Okay, let's one down here. Okay, so here's Pascal's law. The P fluid, or pressure of fluid, is equal to T times G times H. Okay. Actually, let's shoot. That should be rho. There we go. So pressure is equal to the density times grams times H. So this is not pressure. Okay. Let's do a quick example. It's not a good one. One moment. Too bad, but I feel like we need to be proper there. But they'll ask you something like, what is the hydrostatic pressure? And that's what this guy is here. P is the hydrostatic. Okay. So let's do the hydrostatic pressure of water. So we'd have to use some information. It really depends. Let's assume we're on Earth. Let's assume we're just dealing with a certain amount of water. So find the hydrostatic pressure. Okay, so the question would probably look like something like this. Rho H2O, that would be equal to the density of water times G times H. So they would have to give you all this stuff. So we have P. I'm going to go ahead and write all the information. Right here. The density of air is equal to 1.2 0.25 kilograms per meters cubed. CH2O equals 1,000 kilograms per meter cubed. Kilograms per meter cubed. Okay, and the density of, yeah, in case it comes up. All right. So the question would have to give you some of the stuff, like the H, the G. P, would you'd have to know it yourself, but you have to look it up, like, which is going to be this thing, one of these things. So it all depends. Okay, so this is rho. I should not use this P bothering me. There we go. So here we go. So this guy's a P, this one is not. So we have to plug in 1,000 kilograms per meters cubed times gravity, which would be 9.8-ish meters per second squared. It's out of space there, so I'm going to have to do that over here. 1,000 kilograms per meters cubed, 9.81 meters per second squared times height, which we'll say is 10 just to make it easy. Okay. So the hydrostatic pressure of H2O would be this guy. So you'd cancel meters and meters is 2 meters, which will get rid of 2 of the 3 here, right? Seconds are going to stay, kilograms will stay. So we'll end up with 10,000 kilograms times 9.81 per second squared. That would be kilograms per 1 meter second squared. There we go. All right. This will become 98,100. This is unit kilogram per meter second squared is actually your Pascal. So let's change this to PA. So that's going to have huge. So let's use our prefixes because we're supposed to be doing that. 1, 2, 3. So we can use 9.81 K Pascal. There we go.
I'm sorry to interrupt, but can you move the paper up?
Oh yeah, sorry.
Thank you.
Sometimes I forget. Okay. 98.1 actually. I've been moving it 1, 2, 3 K Pascal. All right, one more formula, and we'll move on to something else because we're just about out of time. Total pressure will be the pressure of the liquid plus the pressure of the air above. So P total. These are in fact P's. It'll be P fluid plus the pressure of the fluid plus the pressure of the surface above the fluid. The air above. Okay. So if you wanted to find the total pressure of that water we just calculated, you'd have to add the atmosphere, right? Assuming it's just air above. So if you have water, the total pressure of PH2O would be that number we calculated, 98.1 K Pascal, plus the atmosphere. So one atmosphere we said is 101 K Pascal, which would give us 191, 99, right? Okay. All right. We're almost out of time here. Probably gonna let you take the exam over next weekend. So next week we'll finish energy and power, and I'll give you the last of the homework. So homework will probably be pushed back sometime late next week. I don't remember the current due date. So I'm thinking Friday. Homework's due, exam due by Sunday of next week. So everything's next week, not this week. So we won't have much time. I don't want to rush it. Anyway, you guys have any questions about this stuff? I'm gonna send you the homework so far. I guess the rest of the homework for homework 4. So I forget.
So the homework that's due tomorrow is not due tomorrow, it's due next week?
Yeah, because that homework only has like 2 parts of it. So you're gonna have like 1 or 2 more sets of homework from today, and then you have one more, maybe 2 from next Monday. So we're gonna group all those little homework problems together as one assignment. So if you finish the other homework, that's great, but you still have some more stuff to do for homework 4. But to answer your question, yeah, I'm gonna move the due date to Friday, next Friday, not this Friday, but.
Okay, thank you.
Do you want it all scanned into one PDF, or do you want it submitted?
Yeah, like just one PDF would be good.
Okay, all right, cool.
Homework 4. So I already sent you 2 parts, right? I can't remember. For the first. Yes. Okay, so I'll send you the rest today. Okay. You guys have any questions? We'll talk more about the exam probably on Monday, but if you have any questions at all, let me know.
No, we're good for now.
Cool. So yeah, I'll email that stuff. Next week we'll talk about exam, and then at the end of the week we'll talk about the next lab and homework. Okay.
Okay.
I guess I'll see you Monday.
All right. Have a good weekend.
You too.
Have a good weekend.